Hello students, I am Dr. Sangeeta Sharma, your science teacher. Today we will be continuing with chapter 12 of your science book, that is electricity. And in today's video, that is part 3 in text exercises, we will be solving the exercises given at the end of the topic of electric potential and Ohm's law. So students, we have studied about the electric potential and Ohm's law, and today we will solve the problems given at the end of these topics. So students, let's begin with the in-text exercises. So students, let's solve the problems. So example 12.2. How much work is done in moving a charge of 2 Coulomb across 2 points having a potential difference 12 volts. Now students, to begin with solving the problem, we will first write the physical quantities which are given. Then we will write the formula used and then we will solve the problem. So here what we are given is that a charge of 2 coulombs. So students, here we are given that Q is equal to 2 coulombs. It is having a potential difference of 12 volts. So V is given as 12 volts, and what we need to calculate? Here we need to calculate how much work is done. So W has to be calculated. Now here students, we will use the formula that V is equal to W upon Q. So this implies that W will be equal to V multiplied by Q. Now here V is given as 12 and Q is here 2. So the work done will be 24 joules. So here students, the answer will be 24 joules. This we have calculated. So the work done here will be, equal to 24 joules. Right students? Now let's see the next question, which is question number 1 given in your textbook. Name a device that helps to maintain a potential difference across a conductor. Now students, we know that for the flow of electric charge, a gradient which is known as potential difference is required. So here we have asked that name a device that helps to maintain a potential difference across a conductor. So students, a source of electricity such as cell, battery or power supply etc. helps to maintain a potential difference across a conductor. So students, the cell, the battery or the power supply are the names of the devices that help to maintain a potential difference across a conductor. Now let's see the next problem, which is question number 2. What is meant by saying that the potential difference between 2 points is 1 volt? Now students, here we need to define the definition of 1 volt. So students, we will write the answer like this. If 1 joule of work is required to move a charge of amount 1 coulomb from one point to another, then it is said that the potential difference between the 2 points is 1 volt. So here students, we gave the definition of 1 volt. So 1 volt is 1 joule upon 1 coulomb. So we can write it as 1 joule per coulomb also. Right students? Now let's see the next question, which is question number 3. How much energy is given to each coulomb of charge passing through a 6 volt battery? Now students, here we need to calculate the energy given to each coulomb of charge passing through a 6 volt battery. Now students, we know that energy given to each coulomb of charge is equal to the amount of work required to move it. बच्चों, एनर्जी और वर्क डन जो है उसकी यूनिट भी सेम होती है और जो वर्क डन होता है वो एनर्जी की फॉर्म में ही स्टोर होता है. तो अगर आपसे किसी क्वेश्चन के अंदर एनर्जी पूछी जा रही है तो आप समझ जाइएगा कि आपको वर्क डन ही निकालना है. ठीक है? नाउ वी नो potential difference delta V is equal to work done upon charge. So we will use this formula to calculate the energy for each coulomb of charge passing through a 6 volt battery. Now students, here what we are given is, we are given the charge is 1 coulomb and the potential is 6 volts. So we need to calculate the energy, that is we need to calculate the work done. Now students, we know that V is equal to W upon Q. So W is equal to V multiplied by Q, and here V is 6 volts and Q is 1. So the work done will be equal to 6 joules. So the work done is 6 joules. This means the energy is again 6 joules. Right students? So let's see the next question. Example 12.3. Part A. How much current will an electric bulb draw from a 220 volt source if the resistance of the bulb filament is 1200 ohms? Now here students, first we will write the quantities which are given, then we will use the appropriate formula and we will solve the numerical problem. So here we are given that we have an electric bulb drawing a potential of 220 volts from the source. So V is given as 220 volts and the resistance is given as 1200 ohms. Now here what we need to calculate is, we need to calculate the current I. Now students, here what formula we will use? Yes, we will use the Ohm's law. So V is equal to IR. This is the formula used. So let's solve this problem. Here V is given as 220 volts and the resistance is given as 1200 ohms and we need to calculate I. So students, I is going to be V upon R. So here V is 220 and R is 1200. So if we are going to divide this, then so on dividing this by 2, we will have a 11 over here and here 2 6 are 12 and a 0. So I am left with 11 upon 60. So I can solve this further. So if I divide 11 by 6, right students, then I'll divide it by a 10 more. So if I divide 11 by 6, then 6 ones are 6. I am left with a 5. And then if I put a decimal over here, then this becomes a 50. So 6 7s are 42, 6 8s are 48. So I'll have a 8 over here. So this will become a 48. I'm left with a 20. So 6 3s are 18. Again I'm left with a 20. So in this way it will go on. So what we are having here is 11 upon 60. Now instead of 11 upon 60, we have divided 11 by 6. So it will be again 1.83 has to be divided by a 10. So what I will get is, I will get 0.183. So here students, we have calculated the current. So the unit will be amperes. So we will draw a current of 0.183 amperes. Here students, keep this in mind that I had divided 11 by 6 instead of 60. That is why I have moved this decimal here in one digit towards the left, because I have divided it again by a 10. That is, in place of 1.83, that is why I have written 0.183 and the current is 0.183 amperes. Now let's see the next part, the B part. How much current will an electric heater coil draw from a 220 volt source if the resistance of the heater coil is 100 ohms? Now here again, to solve the numerical problem, we will write the quantities which are given. So here for the solution, what we are given is that the electric heater coil draws from a 220 volt source. So the potential is again 220 volts. Then the resistance of the heater coil is given as 100 ohms and we need to calculate the current. So again we will use the formula V is equal to IR. So I will become equal to V upon R and V is again here 220 volts and the resistance is 100 ohms. So what we get is that the current is now this 0 will go by this 0, and if I divide 22 by 10, I'll get 2.2 amperes. So the current drawn by an electric heater from the same potential source and with a very low resistance is going to be high. There we had a 1200 ohm resistance, and here we have only 100 ohm resistance. So here the current drawn is more as compared to the previous case. Now let's see the next question. Example 12.4. The potential difference between the terminals of an electric heater is 60 volts when it draws a current of 4 amperes from the source. What current will the heater draw if the potential difference is increased to 120 volts? अब बच्चों यहाँ पर पोटेंशियल डिफरेंस जो है वो एक इलेक्ट्रिक हीटर का दिया हुआ है कि जब पोटेंशियल डिफरेंस जो है वो 60 वोल्ट्स का होता है तो वो 4 एम्पेयर का करंट ड्रॉ करता है, और वही इलेक्ट्रिक हीटर जो है वो कितना करंट ड्रॉ करेगा अगर उसके पोटेंशियल को हम 60 वोल्ट से 120 वोल्ट्स तक इंक्रीज कर दें। तो स्टूडेंट सबसे पहले हम क्या करेंगे, यहाँ पे क्वांटिटीज जो दी हुई हैं उनको लिखेंगे, और 60 वोल्ट सोर्स से 4 एम्पियर करंट ड्रॉ कर रहा है तो पहले हम सबसे पहले उस इलेक्ट्रिक हीटर का रेजिस्टेंस निकालेंगे। अब इलेक्ट्रिक हीटर तो चेंज हुआ नहीं तो उसका रेजिस्टेंस तो सेम रहेगा, फिर हम 120 वोल्ट्स के लिए ये निकालेंगे कि वो कितना करंट draw करता है, right students? So here for to begin with the solution what we have is that initially the potential difference is 60 volts and the current drawn is 4 amperes. So first we need to calculate the resistance. Then when the potential becomes 120 volts we need to calculate I dash, and R is going to be the same. So here we will use the Ohm's law, students. So 60 volts and 4 amperes. So we will use V is equal to IR, which is the Ohm's law. So this gives us that the resistance is given by V upon I. So we will calculate the resistance V upon I, and here V is given as 60 volts and I is given as 4 amperes. So students, we need to calculate this R. So here R will become equal to V is 60 and I is given as 4 amperes. So we will divide this, 4 ones are 4, we are left with a 20, so 4 5s are 20. So the resistance is 15 ohms. Now the electric heater is the same and the potential has increased to 120 volts. So now we need to calculate the current drawn. So again students, we will have the same formula. So here we will have V dash is equal to I dash R, and we need to calculate this I dash. So this implies I dash will be equal to V dash upon R. Now since V dash is 120 and R we have calculated as 15. So we need to solve this. So if I cancel this, if I divide this by a 5, so 5 3s are 15, and here I'll have 5 2s are 10 and 5 4s are 20. If I divide this by the 3, then 3 8s are 24. So what we get is that the current drawn now is 8 amperes. So what we see is that if the potential is increased for the same device, then the current drawn also increases. Initially it was 4 amperes and now it is 8 amperes. Now let's see the next question. Example 12.5. Resistance of a metal wire of length 1 meter is 26 ohms at 20 degrees centigrade. If the diameter of the wire is 0.3 mm, what will be the resistivity of the metal at that temperature? Using table 12.2, predict the material of the wire. Now students, again to begin with, we will first write the quantities which are given. Now the resistance of a metal wire is given to be 26 ohms. So R is given as students 26 ohms. Then the length is given as 1 meter and the diameter of the wire is given as 0.3 mm. Mm means millimeters. Now millimeters has to be converted into meters. So what we will do is, students, D will be equal to 0.3 into 10 to the power minus 3 meters, because we know that 1000 millimeters gives us 1 meter. So we will have 0.3 into 10 to the power minus 3. For simplicity, we can write it as 3 into 10 to the power minus 4 meters. Now here, students, this is B. So now, students, we need to calculate the resistivity of the metal. Now we need to calculate rho. Now here, the quantities which are given, that I have written, and the quantity which has to be calculated, that I have written. Now what formula we are going to use? Yes, students, we will use the formula that R is equal to rho L upon A. Now here we need to calculate rho. So the formula will become, this implies that rho is equal to RA upon L. Now students, area of cross section, we need to calculate A. So A is given by pi r square. Now instead of radius, what we are having? We are having diameter. So we know that the half of diameter gives us the radius. So here for pi r square, what we will write is pi d upon 2 square upon L. So the resistivity is R into pi d square upon the 2 is also having a square, so we can write L into 4. So we now need to substitute the values. So the resistance was given as 26 ohms. So what we will write here is 26. Now the value of pi can be taken as 3.14 or you can take 22 by 7. Then D. So D is given by 3 into 10 to the power minus 4 square. Then we have L, which was given as 1 into 4. So this we need to solve. So on solving this, what I get is 26 into 3.14 into 3 square means 9. And this becomes 10 to the power minus 4 square. So it will become minus 8 upon 4. So I'll divide this 26 by 4. So what I will get is 4 5s are 20, 4 6s are 24. Then I am left with a 20. So 6.5. So this 26 is divided by 4 and what I get is 6.5. बच्चों ये आप करके भी देख सकते हैं. 26 को यदि मैं 4 से डिवाइड करूं तो क्या होगा? 4 5 जा 20, 4 6 जा 24, 2 बचेगा, डेसिमल लगाएंगे 20 बन जाएगा, तो यहाँ पे 5 ले लेंगे तो 4 5 जा 20, तो 6.5 आ जाएगा. तो 6.5 मल्टीप्लाइड बाई 3.14 मल्टीप्लाइड बाई 9 इंटू 10 to the power minus 8. Now first we need to multiply these quantities. So let's first multiply 6.5 into 9. So what I get is, so here I'll multiply 6.5 by 9. So students, 9 5s are 45, so I'll have a 4 over here. 9 6s are 54, 54 plus 4, I'll get a 58. So the decimal was here, so I'll have 58.5. Now this 58.5 has to be multiplied by 3.14. So this has to be multiplied by 3.14. So I'll multiply this. So 4 5s are 20 with a carry of 2. 4 8s are 32 plus 2, 34 with a carry of 3. 4 5s are 20, 23. Then I have to multiply this by a 1. So 1 5s are 5, 1 8s are 8, 1 5s are 5. Then I need to multiply it by 3. So 3 5s are 15 with a carry of 1, 3 8s are 24 with 1, 25 with a carry of 2. So 3 5s are 15 plus 2, 17. So students, I'll solve this, and what I get is, here I'll get a 0, 5 plus 4, a 9, then 8 plus 5, 8 plus 5 is 13, and 3, 16, so I'll have a 6 over here, then a carry of 1, 10, 11, 12 and 13 with a carry of 1, then a 8 over here and 1. Now students, since I had 3 decimals, like after the decimal I have 3 digits, 2 here and 1 here. So I'll put a decimal after 3 digits. So what I get is, I get 183.690 into 10 to the power minus 8. Right students? Now this is rho, and the unit of rho is ohm meter. Now this I can write it as 1.837 into 10 to the power minus 6 ohm meter. This I can write students, because here I had a minus 8, so I have shifted the decimal over here, and now I'll have a minus 6. So this is the resistivity. Now let's check the table and predict which is this substance. So students, 1.8 into 10 to the power minus 6. Now let's find out 1.84 into 10 to the power minus 6 ohm meter. So this is basically manganese. So students, you will write that the substance is manganese. Right students? Now here, let's move to the next problem. That is example 12.6. A wire of given material having length L and area of cross section A has a resistance of 4 ohms. What would be the resistance of another wire of the same material having length L upon 2 and area of cross section 2A? Now students, here a wire of a given material is given, so the resistivity will be the same, because we know कि resistivity जो होती है students, वो characteristic property होती है किसी material की. अब material को तो change किया नहीं, तो उसका resistance तो change होगा, पर उसकी resistivity change नहीं होगी. तो यहाँ पर अभी हम देख लेते हैं कि हमें क्या क्या दिया हुआ है, उनको लिख लेते हैं फटाफट से, और फिर इस numerical problem को solve करते हैं. So students, to begin with, we'll first write the quantities which are given. A wire of given material having length L and area of cross section A has a resistance of 4 ohms. What would be the resistance of another wire? We have to calculate the resistance of another wire of the same material. This means if here the resistivity is rho, then the resistivity here is also rho, having a length of L upon 2. So here this is L dash, and the area of cross section is 2A, that is A dash is 2A. So we need to calculate the resistance of this wire. So students, here first we will write the formula for resistance. So R is equal to rho L upon A, and this is given as 4 ohms. Now the new resistance R dash will be given as rho L dash upon A dash. So here students, R dash will be equal to rho, L dash is given as L upon 2 and A dash is given as 2A. So what we get is, we get 1 upon 4 rho L upon A, which is, this is equal to the original resistance. So R dash becomes equal to 1 upon 4 of R. That is, we can write it as R upon 4. So what we see is that the resistance has reduced 4 times. So now students, initially the resistance was 4 ohms. So substituting the value, R was 4. So this becomes 1. So the new resistance here becomes 1 ohm. So students, the new resistance is 1. Right students? Now let's see the next question. On what factors does the resistance of a conductor depend? This we have done, students, that the resistance depends upon 4 factors. So we'll write the answer like this. The resistance of a conductor depends upon the following factors. A, length of the conductor. B, cross-sectional area of the conductor. C, material of the conductor. And D, temperature of the conductor. And students, we know that how they depend upon these factors. We know the formula. R is equal to rho L upon A. That is, resistance is directly proportional to the length of the conductor. Resistance is inversely proportional to the area of cross section of the conductor, and rho indicates the material of the conductor since it is the characteristic property of the material. Then students, question number 2. Will current flow more easily through a thick wire or a thin wire of the same material when connected to the same source? Why? Now students, here we must know that what does a thick wire and a thin wire mean. Thick wire का मतलब क्या हो गया students? मोटा वायर. मोटा वायर मतलब जिसका area of cross section ज़्यादा हो. Thin wire का मतलब क्या हो गया? पतला वायर. पतला वायर मतलब क्या हो गया? जिसका area of cross section कम हो. तो स्टूडेंट्स, हमें पता है कि रेजिस्टेंस जो है वो इनवर्सली प्रोपोर्शनल होता है एरिया ऑफ क्रॉस सेक्शन के. यानी जितना ज्यादा एरिया ऑफ क्रॉस सेक्शन होगा उतना कम रेजिस्टेंस होगा, और जितना कम रेजिस्टेंस होगा उतना ज्यादा करंट होगा. तो स्टूडेंट्स, यहां पर हमें क्या देखना है कि करंट किस में ज्यादा होगा, थिक में या थिन में. तो थिक वायर के अंदर करंट ज्यादा होगा. क्यों? क्योंकि थिक वायर का रेजिस्टेंस कम होगा. तो स्टूडेंट्स, आंसर को हम इस तरीके से लिखेंगे. रेजिस्टेंस ऑफ अ वायर R is equal to rho L upon A, where rho is resistivity of the material of the wire, L is length of the wire, A is area of cross section of the wire. Resistance is inversely proportional to the area of cross section of the wire. Thicker the wire, lower is the resistance of the wire, and vice versa. Therefore, current can flow more easily through a thick wire than a thin wire. Right, students? Now let's see the next question. Question number 3. Let the resistance of an electrical component remains constant while the potential difference across the two ends of the component decreases to half of its former value. What change will occur in the current through it? अब स्टूडेंट्स, यहाँ पे क्या कहा है? लेट द रेजिस्टेंस ऑफ एन इलेक्ट्रिकल कंपोनेंट रिमेन्स कांस्टेंट. यानी कि एक जो रेजिस्टेंस है किसी इलेक्ट्रिकल कंपोनेंट का वो तो चेंज नहीं हो रहा है. क्या चेंज हो रहा है? पोटेंशियल डिफरेंस चेंज हो रहा है. और पोटेंशियल डिफरेंस इनिशियली अगर V है तो बाद में उसका पोटेंशियल डिफरेंस कितना हो गया? डिक्रीजेस टू हाफ ऑफ इट्स फॉर्मर वैल्यू. यानी कि शुरुआत में अगर पोटेंशियल डिफरेंस को अगर हम V ले रहे हैं तो बाद में पोटेंशियल डिफरेंस कितना हो रहा है? V upon 2. What change will occur in the current through it? तो रेजिस्टेंस तो सेम रहे और पोटेंशियल जो है वो अगर डिक्रीज होकर हाफ हो जाए तो करंट कितना हो जाएगा? करंट में क्या चेंज हो जाएगा? तो स्टूडेंट्स, वी विल राइट द आंसर लाइक दिस. द चेंज इन द करंट flowing through the component is given by Ohm's law. As V is equal to IR, so I will be equal to V upon R, where resistance of the electrical component is R, potential difference is V, and current is I. The potential difference is reduced to half, keeping resistance constant. So let the new resistance be R dash and the new amount of current be I dash. Therefore, from Ohm's law, we obtain the amount of new current. So the new current will be given by V dash upon R dash. Now since the resistance hasn't changed, so in place of R dash we have written R, and the potential has decreased to its half value. So in place of V dash we have written V upon 2. So what we get is, students, that half V upon R. So V upon R is, students, I. So what we get is that the new current is again half of its initial value, that is I upon 2. Therefore, the amount of current flowing through the electrical component is reduced by half. So in this way we have calculated the current for the new system. Right, students? Now let's see the next question, which is question number 4. Why are coils of electric toasters and electric irons made of an alloy rather than a pure metal? तो स्टूडेंट्स यहाँ पे हमें क्या बताना है कि एलॉय, उसके जो कंस्टिट्यूएंट मेटल्स हैं उन्हीं से तो एलॉय बना हुआ है. तो यहाँ पर स्टूडेंट्स हमें क्या बताना है कि हम एलॉय क्यों यूज करते हैं इलेक्ट्रिक टोस्टर और इलेक्ट्रिक आयंस को बनाने के लिए प्योर मेटल्स की जगह. तो स्टूडेंट्स हमें पता है कि इसके हमारे पास में 2 रीजंस होते हैं. तो हम आंसर इस तरीके से लिखेंगे. द रेजिस्टिविटी ऑफ एन एलॉय इज हायर देन द प्योर मेटल. मोरओवर, at high temperatures the alloys do not melt readily. So these are the 2 reasons, students. First, the resistivity of an alloy is higher, and second, that at high temperatures the alloys do not melt. Hence, the coils of heating appliances such as electric toasters and electric irons are made of an alloy rather than a pure metal. Now let's see the next question. Question number 5. Use the data in table 12.2 to answer the following. Which among iron and mercury is a better conductor? And B part, this was the A part, and the B part is which material is the best conductor? Now students, here we have to observe table 12.2 and then we have to answer these 2 questions. First we need to compare iron and mercury and we have to tell that which is a better conductor. तो बच्चों हमें पता है कि जिसकी रेजिस्टिविटी ज़्यादा होगी उसका रेजिस्टेंस भी ज़्यादा होगा, तो वो करंट को अच्छे से फ्लो नहीं होने देगा, यानी कि वो ज़्यादा अच्छा कंडक्टर नहीं होगा. तो यानी कि आयरन और मरकरी में से जिसकी रेजिस्टिविटी कम होगी वो ज़्यादा अच्छा कंडक्टर होगा. तो हम टेबल के अंदर देखेंगे कि इन दोनों की रेजिस्टिविटीज़ को हम कंपेयर करेंगे और जिसकी रेजिस्टिविटी कम होगी वो ज़्यादा अच्छा कंडक्टर होगा. और दूसरे क्वेश्चन में ये पूछा है विच मटीरियल इज द बेस्ट कंडक्टर, तो मतलब जिसकी रेजिस्टिविटी सबसे कम होगी वो बेस्ट कंडक्टर होगा. तो स्टूडेंट्स देखते हैं टेबल. So students, if we compare the values of resistivity for iron and mercury, then what we see is that the value of resistivity for iron is 10 into 10 to the power minus 8 ohm meters, and for mercury it is 94 into 10 to the power minus 8 ohm meters. So which has the lower value? Obviously iron has the lower value of resistivity. So iron is a better conductor. Then in the next part they have asked, so for the part A the answer is iron, and for the B part they have asked which is the best conductor. So the lowest resistivity if we see is this 1.6 into 10 to the power minus 8 ohm meters, and this corresponds to silver. So this is the best conductor. So students, for the answer writing you will write for A part resistivity of iron is 10.0 into 10 to the power minus 8 ohm meters, and resistivity of mercury is 94.0 into 10 to the power minus 8 ohm meters. Resistivity of mercury is more than that of iron. This implies that iron is a better conductor than mercury. It can be, for the B part we'll write the answer that it can be observed from table 12.2 that the resistivity of silver is the lowest among the listed materials, hence it is the best conductor. So students, here we have solved all the in-text exercises given at the end of the topic electric potential and Ohm's law. Now students, we have done this topic, and for the next video we'll start with a new topic. Till then, stay safe, stay healthy, bye.